Okay, now let's have a look at the bilinear transformation, which is a nonlinear transformation, avoiding aliasing uh, because of the nonlinearity of the uh, transformation involved. So, as we saw that we have to start from a filter HC of j of omega that is in the continuous domain, and then let's suppose that this is this filter, this is omega axis, and then the mapping from omega to small omega has to be plotted. Now, in that case, what we say is that the value on which we want on small omega to be limited is pi, right? So the function which non-linear function in comparison to a linear function has been given here. तो अगर ये linear होता तो इस तरह की कोई लाइन ड्रॉ होती, straight line ड्रॉ होती. But this one is a non-linear function, तो इसलिए हम इसको तो consider नहीं कर रहे. We are only considering a non-linear function. Non-linear function के केस में हमने देखा था we have impulse invariance. Now this function has to be mapped, and the new signal that we will get will be He of j omega mod. So this He of j omega mod, let me write it like this instead of this. He of j of omega mod will be that if you start one-to-one mapping, so you drop a line from Hc of j omega, straight line, from Hc of j omega to the function which is nonlinear, and then you map it here, you start mapping it here on He of j omega axis. Kind of जो आपके पास फंक्शन बनेगा that will be He of j omega, and that will be limited function. तो आपके पास जो एक लिमिट तक आएगा, ये नहीं होगा कि वो जो है ना this limit is actually pi. मैक्सिमम अगर जाएगा तो यहाँ तक जाएगा, pi तक जाएगा. It will not alias into uh, or a value greater than pi, because ये जो है ये इससे आगे जा ही नहीं रहा. तो ये एक फायदा है this bilinear transformation, that it doesn't touch this, does not touch the pi line. तो वो चूंकि pi line को टच नहीं कर रहा, तो इसका मतलब है कि वो एलियसिंग ही नहीं हो रही. तो जो इस तरफ सिमेट्री की दूसरी तरफ सिग्नल होगा वो एलियस नहीं करेगा इस वाले से, राइट. दिस इज बेसिक एडवांटेज ऑफ डूइंग bilinear transformation. Okay, so another thing which I wanted to mention was that HC of S in the case of um, this bilinear transformation, you can replace S by this equation. Okay, so 2 over t into 1 minus the inverse over 1 plus the inverse, and z in this case can also be written as 1 plus st over 2 over 1 minus st over 2. Okay, and s basically is sigma plus j of omega. Given that you have j omega only and sigma equal to 0, then you can also write j omega as 2 over t 1 minus t inverse over 1 plus z inverse. Okay, where z can also be replaced as r e raised to power j of omega. Okay, so this is actually j of omega. Also, if you write r equal to 1, then this can be simplified as this equation. Okay, further reducing it, you can write it as e raised to power minus j omega over 2, e raised to power j omega over 2, minus e raised to power minus j omega over 2, e raised to power minus j omega over 2, over e raised to power minus j omega over 2. Thereby, it can also be written as 2 over t, and e raised to power minus j omega over 2 can be taken out as common. E raised to power j omega over 2 minus e raised to power minus j omega over 2 over e raised to power minus j omega over 2 can also be taken out here. Expansion j omega over 2 minus e raised to power minus j omega over 2. If there is a plus sign as well. तो हमें पता है इसको हम लिख सकते हैं साइन की फॉर्म में और इसको हम लिख सकते हैं कॉस की फॉर्म में so you can divide both by 2. Okay, and also you can divide this by j, multiply by j as well. These two get cancelled, and you can write it as 2j over t sine of omega over 2 over cos of omega. So this is actually j of omega. Now these j's can also cancel with each other, and you have this as 2 over t tangent of omega over 2. Okay, so capital omega is actually equal to 2 over t tangent of omega over 2, or in other words, you can take omega t, you can move omega t here, and you will have tangent of omega over 2, and then this can also be written as tangent inverse of, or r tangent of, r tangent of equal to omega over 2. Okay, so this 2 goes here. You can just write it here. So small omega is actually equal to 2 arctangle of capital omega t over 2. So this is finally the expression of converting a continuous time frequency into um, there is a continuous time frequency and you want to convert it to a discrete time. तो इस फॉर्मूले से आप कर सकते हैं if there is a discrete time frequency तो आप उसको continuous time में इस तरीके से convert कर सकते हैं. Okay. So I hope that you have understood the overall theme of how this formula of phasor inverse is used to convert from from continuous time to discrete time and similarly from discrete time to continuous time.